So let's kind of analyze what's happening. And the PVA card would be very helpful if you want to take that out. So it says f prime of x is positive and increasing. So let's kind of analyze. If f prime of x is positive and that same value is increasing. So looking at my PVA card, when f prime is positive, the graph is doing what? The graph is going up, okay? And then it says, if f prime is increasing, my graph is going what?
Concave up.
It is concave up. So f prime of, oh, that's an x, by the way, is positive, and the graph is concave up. So what's given is all of our f graphs. So I'm going to worry about these guys over here. Where is it increasing and where is it concave up? Automatically, can we look at the concavity right here? Between which two values, a to b, is it concave up? B to C, C to D, and D to E. Do y'all see D to E has concave up right here? Okay, and it's increasing at that point. So that's got to be which letter? E it is. Don't miss it. And just like last time, if you know you can get this one, put a check mark. If you now understand, it's a potential, and then X for absolutely not. Hopefully this is absolutely yes. Okay, on number 7. Quinn, let's read.
Let f be a function that continues in the closed interval 2 to 4 with f2 equals 10 and f4 equals 20. Which of the following is guaranteed by the intermediate value theorem?
Okay, looking at the intermediate value theorem, and if you're like, which flashcard is this? It is flashcard number 1B. So intermediate value theorem says it is continuous. Was that stated on the question? Yes. So that means somewhere in between something is going to exist. I can show you visually, but I'm going to show you first by the theorem. Okay, so if that didn't make sense, I'll go ahead and give you the visual. So if I mimic what's happening right here, my a to b is 2 to 4. So I'm going to write f of 2 is less than a number, less than f of 4. That is strictly from the flashcard. And if I specifically write out what is the value of f of 2, what's the y value at f of 2? Do we see 10? And the y value at f of 4 is how many? 20? So let's see which one satisfies that. Part A says there's a y value of 13 at least one time in the solution. Is that true? Does 13 exist? That has to be the right answer. And then I'm going to show you visually for part B, and if you're good on that, I'm going to move on. Okay? So here's my visual. So here's my 2, here's my 4, here's my 10, and here's my 20. Let's go ahead and locate it. Is he writing? Please do. Right. So f of 2 is 10, and then we have 4 is 20. And I'm going to show you why at 3 it's not guaranteed, it's got to be 15. So I'm just going to kind of gauge. 3 is over here, and 15 is around over here. So I'm just kind of guessing, can it go through this point? As long as these two are connected, if I chose to make my line go like this, is it guaranteed that it's going through 3, 15? No. As long as they're connected, it doesn't matter how you draw it. Is everyone good with that? So I can give you a scenario on every single one of them, but I'm not going to because I strictly used my flashcard number 1B. If y'all are good with that, give me a thumbs up. Okay? All right. Let's go on to number 78. Lily, go ahead and read that one.
The graph of y equals e to the power of tangent minus 2 crosses the x-axis. At what point in the interval 0? What's this thing?
Okay, let's underline crossing the x-axis. When a graph crosses the x-axis, that means that we're crossing at y equals 0. So I'm going to have you write y1 is equal to 0. And then all this right here, we're going to type in y2. So I want to figure out the intersection first. And then we'll deal with the slope. And for the slope, let's also write on here, the slope is found by y prime. So the first thing is my intersection. So type in with me. So we have on this one, oh, I already had that typed in. Silly me. So my y1 is going to be, there's a trick that I did. Did I do a trick? No? Let's take it traditionally and see what happens. And then let's type in, we have e to the power of tangent of x, tangent of x, and then all minus 2. Is everyone good with that? Okay. And I'm just going to go to Zoom 6, because 10 by 10 is pretty friendly. And you might be thinking, why did you do that? Because we had the interval given, but at least we know where between 0 to 1 is, right? Would you agree this point is where I'm going to find the intersection right there? I think I kind of wrote on it. So we have second count, 5. I'm going to hover pretty close to it. And when I press enter 3 times, it's going to give me, my value is 0.606. So here is what I would do. Because you don't want to round as you go, on your home screen, click on store. Click on the X that we just found the intersection of, and it's going to remember what that number is. So anytime you write in the X on there, it's going to remember it's 0.606, blah, 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 not rounded. So now, that's the first step. Second step now is the slope. Let's see if y'all remember the trick on the calculator. Was it math 9 or math 8 for the derivative? Math 8. So we have math 8, and we have dx. Now keep in mind, you don't have to type in the whole equation again. You can go to vars, y vars, the function. I had my function in y2. Okay, here's the next part that's kind of unique. It's asking you to type in the value, right? Didn't we already store the x value? Just go ahead and type in x. It's going to remember the ugly decimal without it being rounded. And when I press enter, what answer choice is correct then? D it is. All right, let's go on to the next page. Okay, cool. Let's read number 79, please.
A particle moves along the x-axis. The velocity of the particle at time t is given by v at t. And the acceleration of the particle at time t is given by a of t. Which of the following gives the average velocity of the particle from time t equals 0 to time t equals a?
Okay, this is very wordy for no reason. The only part you need is the average velocity. And from there, if we look at flashcard number 8B, this is the average of the function. So I'm going to mimic what's happening on this one. So if I tell you my average, well, this is my average of the function, correct? So if I do the average velocity, instead of f of x, I'm plugging in v of t. Does that make sense? Okay? So that will mean we have 1 over b minus a. B minus a is 8 minus 0. And they told us from the lower bound is 0, upper bound is 8, of v of t dt. And which one has that automatically? B it is. Now, AP Tester could also give you another way of mentioning this. Okay? So let's write out PVA real quick. So the position, derivative of the position is velocity, correct? So that means if I find the slope of the position, that is a velocity, right? So our position is noted by x-axis. So I could do y2 minus y1 over x2 minus x1, which can look like x of 8 minus x of 0 over 8 minus 0. If that happens, that could be an answer choice, and our original answer choice will not be on there. Is everyone good with that? Hopefully you know automatically, though, D and E did not have 8 on the bottom, so that was a bad answer choice. Good? Okay, if you're good to move on to the last one, give me a thumbs up. Okay. On my last one, Nev, let's read 80.
The graph of f prime, the derivative of the function f is shown as above. Which of the following statements cannot be true?
Okay, let's look at each one of them. So I'm going to look at part 1. It says f has a relative minimum at -3, so put a dot right there. And the graph that is given is f prime, so let's look at this one. There is a relative minimum, or I'm going to start with maximum. There is a relative maximum when f prime is going from positive to negative. So that means there's a minimum when I'm going from what? Negative to positive. Let's see if that's true. Negative to positive. Is that true? So we know 1 is true. So just by that, I can eliminate B and C. Is everyone good with that?
Yes.
Okay. The next one says, since 2 is still available, we need to analyze that. The function has a point of inflection at -2. So let's kind of think about it. The function has a point of inflection when f prime is changing directions. So at -2, here's my -2. So I'm going to go to my graph. I'm going up, and I'm still going up. Is that changing direction if I'm going up and up?
No.
No. So we know that's not true. So just by that, I can eliminate what? D. So now I'm forced to check the last one. The graph is concave down from 0 to 4. So it is concave down when f prime is strictly going down. Do we all see that? Okay? So from 0 to 4. Here's my 0. Here's my 4. I'm going down and I'm going down. Am I strictly going down? So we know that's got to be E.